Class 2 of week 4, we're going to look at solving quadratic equations. Remember before that a quadratic expression is something that looks like ax squared plus bx plus c is equal to 0, where a and b and c are all numbers. Now, what we do find is that it may well have two real solutions. It may have one solution, or in actual fact it may have no real solutions. If we can factorize, then we can solve a quadratic really easily. Before we go on to actually looking at solving them, let's just have a wee think about what a quadratic that's got two solutions, one solution or no solution looks like. The first one, if it's got two real solutions, it looks something like that. It's got two values of x where it crosses the x-axis. Where it's got a single solution, it's something that looks like that, where it just touches once. If it's got no real solutions, then it's something like that, where it doesn't actually cut the x-axis at all. Think back to topic 2, where we were factorising, and let's look at factorising x squared plus 8x plus 12. Remember that we need two numbers to multiply to make 12, and we also need them to add, in this case, to make 8. Not too difficult then to find two numbers that multiply together to give 12 and add to make 8. That will be 6 and 2. So then we can say that x squared plus 8x plus 12 is going to be x plus 6 and x plus 2. We kind of now, you can check that using the smiley face or FOIL to get backwards to x squared plus 8x plus 12. We need to look for numbers now that actually multiply so that AC is equal to 24 and B is equal to 11. So we're going to have to do a little bit of trial and error. Let's look 8 and 3. Okay, so that means then that what we've got would be that 4x squared plus 8x plus 3x plus 6 would work. And if we factorize that, we get 4x times x plus 2 plus 3 times x plus 2. And taking the final factors, taking out a common factor of x plus 2, then we're left with 4x plus 3. Similarly, we can do that with the next one. We can find that AC is equal to negative 72 and that B is equal to 1. So our choices there are 9 and negative 8. Which means we can rewrite 12x squared plus x minus 6 as being 12x squared plus 9x minus 8x minus 6. And if we rearrange that, then we're going to end up with 3x minus 2, 4x plus 3. If we look at x squared plus 16x plus 64, then again we can go through the logic. We can see that x squared plus 8x plus 8x plus 64 is what we had, and then if we rewrite that, we can rewrite it as x plus 8 times x plus 8. For the next one, we can either remember that it's the difference of two squares, or we can use the same logic as before, that AB equals negative 49 and that A plus B is equal to 0. There's no term in there, and the only numbers that works for are x minus 7 and x plus 7. And check it out by multiplying it back. Once we've factorised, then we make use of the fact that something times something equals 0, then either the first something is equal to 0 or the second something is 0. That doesn't just have to be AB. It could be that if x plus A times x plus B equals 0, then x plus A is equal to 0, or x plus b is equal to 0. And it's that fact that we use to solve these equations. Okay, the first one is going to factorise as x plus 5, x minus 2 equals 0. So that means that x plus 5 equals 0, which means that x equals negative 5, or that x minus 2 equals 0, so that x equals 2. The next one factorises to 3x plus 4 and 2x minus 1 is equal to 0. So then 3x plus 4 equals 0, which means that x is equal to negative 4 over 3, or 2x minus 1 equals 0, so x equals a half. The third example there only has two terms. Now, if it's a quadratic and it's only got two terms, then we can factorise it slightly differently. We can factorise it by taking out a common factor of 8. And then using the same logic, we can see that x equals 0, or x minus 8 equals 0, which means that x equals 8. The last one, we can remember that it's the difference of two squares, or we can just take the square root of each side. But just remember, and this is something students often get wrong, that it's plus or minus 9. There are two answers. Okay, sometimes you're not going to be able to factorise, and if you can't factorise, if you can't see the factorisation even, then you're going to have to use the formula. The formula will be given to you in the exam, and it says that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And after that, it's just number crunching. Okay, you're just going to put the values in. The difficult one is where you've got a minus sign and a minus sign there. Otherwise, it's just colouring by numbers, painting by numbers. I'll give you the solution so you can check negative 4 and negative 5. The next one to 3dp. The third one has one root, x equals negative a half. And the fourth one has no real roots. Because when you come to use the formula, b squared minus 4ac happens to equal -4, and then you're trying to take the square root of a negative number, and you can't. Well, you can, but it's not a real number. Now we're going to look at using a quadratic equation in a, inverted commas, real solution. We've got a rectangular pool measuring 13 meters by 5 meters. You need to draw a diagram. There's your pool, and then you've got a path around the outside. So that's 13 by 5, and the width of the path is something you don't know. Right, you've got a picture, you now need to work out the maths. So, got little squares on the corner. And each of those squares is x by x, so we have 4 of them. And then we have 2 pieces that are 13 by x. And then we have 2 pieces that are 5 by x. And that's equal to 78 square meters. Okay, that's not too far off being a quadratic. If we simplify, we get 4x squared plus 36x. Put the 78 onto the left, so minus 78 is equal to 0. And using the formula, we can find that x equals 1.805. It also equals -10.805, but that's not possible. So you need to put some reference to that. But that's not possible. Make sure you're going to put in some sensible units. It's 1.805 meters. Just check, was that the question? The question said find the width of the path. Yes, I found the fact that the width of the path is 1.805 meters. That seems to be the answer. We already discussed how many possible solutions there are, but now we're going to actually quantify it using the formula. If b squared minus 4ac is positive, then there's going to be 2 real solutions. If b squared minus 4ac is equal to 0, then there's going to be 1 real solution. And if b squared minus 4ac is negative, then there's going to be no real roots, because you're trying to take the square root of a negative number. We could do it graphically. The solution is where the curve crosses the x-axis. So where y is equal to 0 gives us our solution. So there's one solution there, and there's another solution over there. They're not nice numbers, so we're not going to find them, but they are there. Similarly, though it's not part of the course, particularly if it's not nice numbers, you can find where a cubic is solved by, again, looking at the places where it cuts the x-axis. If you're going to do this in 4102, the cubic will be a nice one, so that where it crosses the x-axis are whole numbers.